Okay, so last on Monday, when it was supposed to be asynchronous snow day, I had left you guys a couple of links on Brightspace. I'm hoping you watch them because they were meant to help you for today's lesson. We're going to be talking about trig. I know those videos sometimes can be kind of funny. I don't know if you found them funny, but I feel they're the most educational and they do such a good job just picturing and visualizing things. I always use them. So if you ever need something other than Khan Academy, it's called Don't Memorize. And it's just so amazing. So what exactly is trig? We're not going to actually take these notes because they were a part of the other lesson, but really trig is a way where when you have a triangle, you relate the side lengths and the angles. And if you watch the videos, by the way, this is on, see the page where it says handout A mixture? That was already assigned to you for homework, so we're not going to do that. It's just the second page of that sheet. If you had done the work on Monday, one of the big takeaways is how exactly we label our right angle triangle. So when you have a right angle triangle, if you have one angle, we're going to call that angle, usually we use the symbol theta. There's a little bit of lag as always. And now according to that theta, we're going to label our side lengths opposite, adjacent, and hypotenuse. The hypotenuse is always across from the right angle. So see how this is the right angle? Right across from it, this is going to be the hypotenuse. And then according to your angle theta, the side length that is closest to it, that is not the hypotenuse, is labeled the adjacent. And then the side length that is as far away as possible is labeled opposite. So that's what this sheet was. I know I had already assigned it to you on Monday for homework. If you didn't have a chance to do it, practice this sheet and the answers are all at the bottom. It's basically just getting you to figure out what's opposite, what's adjacent, what's hypotenuse over and over again until you get good at it. But was this kind of easy to understand? I cheated a little bit. On Monday, I actually gave you the lessons for the entire week. So if you actually went through it, you've learned everything we're going to learn today and tomorrow. I figured if you're really bored during a snow day, what better thing to do than learn math? And so that's why I just gave you a lot of work. Okay, so like I said, trigonometry is all about relating angles and side lengths. And there are 3 different trigonometric ratios that we're going to be learning in grade 10. When you get to grade 11, you learn 3 more. Sine is the ratio of the opposite to the angle. This is too confusing to understand. The way I remember it is sine is equal to opposite over hypotenuse. And the little acronym for this is called SOHCAHTOA. And as long as you remember this, and I often use this, SOHCAHTOA, you will always remember what is related to what. So sine is the ratio of the leg opposite the angle to the hypotenuse. Cosine is the ratio of the leg adjacent to the angle to the hypotenuse, and tangent is the ratio of the leg opposite to the angle to the leg adjacent to the angle. I really hate math definitions because they don't make a lot of sense. It just makes sense to figure out what exactly is happening. So we're going to remember to figure out what sine is, you are going to take, actually, I'll just write it on the sign. If you're trying to figure out sine of an angle, you're going to take the opposite side length and you're going to divide it by the hypotenuse. If you're figuring out the cosine of an angle, you're going to take the adjacent side length and divide it by the hypotenuse. And if you're taking the tan of an angle, you are going to take the opposite side length and divide it by the adjacent. And that's where this acronym SOHCAHTOA comes from, because SOH is for sine, CAH is for cosine, and TOA is for tangent. And all this means is if you're trying to figure out the angle, what you're going to be doing is you're going to be dividing 2 of the side lengths to figure out that angle. The words sine, cos, and tan are always going to be attached to an angle. And this side is always going to be the ratio. So an easy way I always say to remember this is your angle and these are your lengths. So they're always the side lengths, like an actual measurement of centimeters, meters, or just units. Okay, let me pause there. I see a question. Question, Samir? Okay, so I'm going to just skip all of this stuff for now. One other thing I do want to make note to you is, how do we label a triangle? Well, we take the vertices and we label them using capital letters. So in this case, we have labeled this triangle A, B, and C. And then the side lengths are always labeled with a little letter, and it's always whatever is opposite. So for example, opposite of angle A, you're going to have side length A. Opposite of angle C, you're going to have side length C, and opposite of angle B, you're going to have side length B. So the angle and the side length are always the same letter. The angles are written in capital letters and the side lengths are written in little letters. So just something as we go through the questions, you will see us talking about. Okay, so I accidentally wrote all of that stuff up there. We're gonna just copy it down here again. So SOHCAHTOA is what I want you to remember for all of the trig we're gonna do. These are just ratios that help us relate angles to side lengths. So sine of, there should be an angle here. Let's say theta is equal to opposite over hypotenuse. Cos of theta is equal to adjacent over hypotenuse. And tan of theta is equal to opposite over adjacent. Oh my gosh, I just keep writing the same thing. Okay, so the best thing to do is just get into some examples. For this example, it says, give each trigonometric ratio as a fraction in simplest form. We're gonna go ahead and do the first one together, and then I'll give you guys a second to do questions 2 and 3, and we'll take it up. So in this triangle, I have triangle A, B, and C, and I have side lengths 12, 5, and 13. Just for extra practice, let's go ahead and figure out what letters all of these would be. So if this is angle A, this is going to be side length A. Coming. If angle B is 90 degrees, this is going to be side length B. And if this is angle C, this is going to be side length C. Now you have to look at what the question is asking. In this case, the question is asking, what is sine of angle A? So do you guys see how this letter over here in capital is, I don't want that. So see how these are all capital A's? That means for the very first question, we actually want to know what is the sine, cos, and tan of angle A, which I've just highlighted over there. So that's the angle we're going to use to figure out all of our ratios. Okay, so how do we do that exactly? Well, what is sine of A? Sine of A is going to be opposite over hypotenuse. And before we start that, we have to actually label what is opposite, what is adjacent, what is hypotenuse. So according to this angle, this is going to be the hypotenuse. I'm just going to label it H because it's right across from the right angle. According to this angle, this is going to be adjacent because it's the closest side length to that angle. And this is going to be opposite because it's the one right across from it. So if you did handout A, that handout would have helped you figure this out. But does anyone have any questions why I labeled it opposite, adjacent, and hypotenuse, or does it make sense? Make sense? Yeah, Safir? You don't have to, you can just do it in your head, but just for our examples, I will label them. Okay, so now when we're doing the question, what is sine of A? You're gonna start with angle A and you're gonna figure out what is opposite, and you're gonna remember the ratio is opposite over hypotenuse. So what is the opposite side length and what is the hypotenuse in this question? Safir? Yeah, opposite is 5 and the hypotenuse is 13. So our ratio would just be 5 over 13. How about cosine of angle A? So angle A is here, and cosine is adjacent over hypotenuse. So what do you think? Yeah. Yeah, good job. It's going to be 12 over 13. And how about the tan of angle A? Tan is just opposite over adjacent. So what do you think? Safir? 5 over 12. Okay, that's for angle A. So that's done. Now, the next set of questions, sine C, cos C, and tan C, they're telling us to figure out what angle C is. So I'm going to erase all of this stuff because now everything's going to change. And now I'm going to figure out all the same stuff for this angle C. That's what they're asking us to do. They're telling us to look at angle C now. And which example am I looking at? It's this one right here. So see how it says C, C, and C? That is what I'm labeling with all my greens now. Okay, so now according to that angle, this is still the hypotenuse. The hypotenuse doesn't change. It doesn't matter what angle you choose, the hypotenuse is always the hypotenuse. But now this side length is adjacent and this side length is opposite. So you can see that even though we have the same triangle, we're labeling the side lengths differently depending on which angle we're looking at. If we were looking at angle A, then we would label it specifically, but now we're looking at angle C, and so we're labeling it opposite, adjacent, and hypotenuse. Okay, let's figure sine. So sine is opposite over hypotenuse. What do you think our ratio will be, our actual numbers? Jordan? Yeah, 12 over 13, good. How about cosine of angle C? Yeah, Hershey? Yep, it would be 5 over 13. And then tan of angle C? Angelique? It would be 12 over 5. Good job. I'm going to give you a second to try questions 2 and 3. However, what do you notice is missing in questions 2 and 3? Yeah, so you're actually going to have to use Pythagorean theorem to figure that out. Just as a reminder, so for example, if you're trying to figure, the Pythagorean theorem would just be a squared plus b squared is equal to c squared. You all have calculators now, so you can use those. And c is always the hypotenuse, and it doesn't matter what you label a and b when you're doing the Pythagorean theorem, because they're both side lengths. I'm going to say, let's just practice question 2. We can skip practice question 3. So go ahead, take maybe 3 minutes and figure out what the hypotenuse is and then what all of the different ratios will be. Okay, so we did question 2 right now, but I didn't record it. So I'm just going to show it to you. These are the answers we got, and we're skipping question 3 because it's more of the same stuff. We're going on to the next page, which is, okay, so here's where you guys are going to need your calculators. And one of the notes that you can see on the side is that you need to make sure your calculator is in something called degree mode. This is very important. If you don't have it in degree mode, you will get the answer wrong. So right now, you're going to check at the top of your calculator. It should have the letter D or DEG. If you want to change it, honestly, it depends on your calculator, but look for the letters DRG on your calculator and click those. You may have to go into the little menu to figure it out. I will come around and I will help you though, especially, okay. All right, so now we're finally ready to actually start solving these questions, and we're going to try them. So question number 4 has 28 degrees. It has the letter X. It has 19 as its hypotenuse. Are we able to use Pythagorean theorem to figure out the third side length? We don't have enough information, right? We only have one side length given. We only have 1 degree. And really, we don't care for that other side length. We only care for the letter X. So the first thing I'm going to do, and you may not need to do this, but I'm going to just keep doing it until you get really good at it. I'm going to label my side lengths opposite, adjacent, and hypotenuse. According to this angle 28 degrees, this is my hypotenuse because it's right across from the right angle sine. This is adjacent, and this is opposite. I'm also going to remind you of our acronym, SOHCAHTOA. Okay, now let's think about this. We have the angle 28 degrees. We're trying to figure out what the opposite side length is, and we have the hypotenuse. Do we have the adjacent side length? No, we don't have the letter A. So that means automatically I know I cannot use this and I cannot use this because both of those have the adjacent side length, which we don't have. So just by process of elimination, I know I have to use sine is equal to opposite over hypotenuse for this question. And for every single one of these questions, you will only be able to use one. You have to figure out which one it is just by looking at what letters you have. So I always just look at my letters. I say, well, I don't have the letter A at all, so I'm not going to use anything with the letter A. Okay, so to do this question, what we're going to do is I want you to write the formula, which is first going to be sine of theta is equal to opposite over hypotenuse. Do we know what theta is? Do we know what the angle is that we're trying to find? Yeah, we know it's 28 degrees. So we're going to write sine 28 is equal to, what's the opposite side length? Good. And what's the hypotenuse? 19. Good. And we're basically trying to solve for x. So according to our equation rules, how do I get rid of that 19? It's already divided. What's the opposite of division? Yeah, I'm going to basically multiply both sides by 19. And when I do that, I'm going to end up getting 19 times sine 28 is equal to x. Does everyone see why I did that or how I got that? I'm basically just taking this 19 and I'm multiplying it to this term over here. That's the idea behind it. I'm going to just show it to you in one other way. If I gave you a question like 3 is equal to x over 5, how would you solve this? Well, you would multiply everything by 5. 5 times 3 is 15, and 5 divided by 5 is just a 1. So basically, all you did is you multiplied the 3 by the 5. Same idea here. When you have a number on the bottom, to get rid of it, you multiply it to the other side. All right, now you're going to get out your calculators, and honestly, a big part of trigonometry is learning how to use your calculator. So if you're using your phones, that's fine because I didn't warn you ahead of time, but don't get used to it because you need to actually practice using your own calculator and understanding where the different numbers are. Whenever I have sine plus or tan, I always put that first into my calculator. So you're going to find the SIN button, the sine button on your calculator. You're going to click it, and then you're going to put 28. And once you do that, you press the equal sign. And you should get 0.469471562. Is that what you guys got? Okay. Don't write that number down. Don't erase it. Now you're going to write multiplied by 19, and you're going to press the equal sign again to give you your final answer. Yep, 8.91. Round to the nearest. How about we just round to 1 decimal place or 2? Okay, let's just round to 2 decimal places. So x is going to equal to 8.92. If this question had units like meters or centimeters, you should have put them down, but it doesn't. So our final answer is just going to be 8.92. And we're basically going to do this 8 times until you guys get really, really good at it. Did anyone not get 8.92? I'll pause here for a second. Maybe. All right, question 5. I'm just going to go sideways. So in this question, we have 41 degrees, x and 32. First, let's label all the side lengths. So the hypotenuse is across from the right angle side. Across from 41 is our opposite side length, and this is our adjacent side length. So in this question, they have given us the adjacent side length. We're trying to find the opposite. We don't know what the hypotenuse is at all. So we cannot use anything with the letter H in it. Which trig ratio are we going to have to use? Good. So we're going to have to use tan. We have no other choice because the question doesn't give enough information. I'm going to start by writing the ratio. Tan theta is equal to opposite over adjacent. Do we know what theta is in this question? Yeah, so we're going to write tan 41. Do we know what opposite is? And do we know what adjacent is? 32. So you're going to do the exact same thing we did before in the previous question. Move the 32 to the other side. And in your calculators, you're going to go tan 41 equal sign times 32 equal sign. Question? Oh, yeah, of course. Oh, that's too much. Is that better? I feel like the writing gets like, I think that's a little better. That's good. What'd you guys get for this question? 27.82 is correct. You got what? We chose to round to the nearest 2 decimal places. Yeah. My box isn't coming up, so I'm just gonna keep going. Question 6. As we get through more of these questions, we can probably pick up our speed a little bit because you guys are getting the hang of it. For this question, we have 21 degrees. This is your hypotenuse. This is opposite. This is adjacent. So what do you guys think we're going to use? Are we going to use sine, cos, or tan if the opposite side length is not given to us? Yeah, we have to use cosine. So we're going to say cos theta is equal to adjacent over hypotenuse. Do we know what theta is? So we're going to say cos 21 is equal to what's adjacent? X, good. What's the hypotenuse? 26. Now I know I have to multiply them. I'm just switching them around so my X is on the left side, but it really doesn't matter. You'll still get the same thing if you write it the other way. So X is just going to be equal to cos 21 times 26. Tell me what you guys get when you round your answer to 2 decimal places. This is what I ended up getting. Let me know if you guys have a matching number. How come in the previous question, I was able to make it into a square and now I can't? Oh, yes, I did it. So then how come it didn't work for this one? I have to do it. Success. 11. Question number 7. So let's label all the side lengths again. We have, this is going to be your hypotenuse. This is going to be adjacent, and this is going to be opposite. Hypotenuse is always across from the 90 degrees, and the opposite angle is always across from whatever the given angle is. So what do you guys think? We don't have hypotenuse here, but we have the opposite and adjacent. What are we going to use? Yeah, tan. Now I like this question. I'll tell you why. Tan theta is equal to opposite over adjacent. Oh, that's so hard to see. It looks so nice on my screen though. How come there are no questions here where the X is at the bottom? Oh, I guess we're coming to them. Do we know our angle? We do, it's 55. Do we know the opposite side length? It's X, and the adjacent side length is 8. So this is just more of the same stuff, but the next 2 questions after this are going to be a little bit different. And I was waiting for them. Okay, for the next question, look at what happens. So we have 33 degrees. This is the hypotenuse. It's across from the right angle. This is opposite, and this is adjacent. The adjacent side length is not given. So what are we going to use? Sine, cos, or tan? Good. So we're going to use sine. We're going to write sine theta is equal to, I feel also this might be a little harder to read, so I'm going to use this. Sine theta is equal to opposite over hypotenuse. We know what theta is already. It's going to be 33 degrees. We know what opposite is. It's 15. And we know what the hypotenuse is. It's x. Why is this question a little bit different than the other ones? Because the x is at the bottom. Good. And when the x is at the bottom, it's a little bit more complicated. We actually have to do 2 steps to get the x by itself. The first step is I'm going to multiply the x to the other side just like I did before. So it's going to become x times sine 33 is equal to 15. You guys all see what I did? I just moved the x to the other side and I multiplied it. But our x is not by itself. What do I have to do to get the x all by itself? Not inverse. I just need to get rid of the sine 33 that's multiplied to it. What's the opposite of multiplication? Yeah, so all I'm going to do is I'm going to move it to the other side and I'm going to divide it. So just make a little note to yourself that when the x is at the bottom, it just requires an additional step. You move the x to this to the front of the sign, and then the sine 33 you move to the bottom, and now you can just solve it as usual. Just be careful. When you're solving this, I highly recommend when you put it into your calculator, you write it like this: 15 division sign bracket sine 33 division bracket. Because sometimes your calculator can do weird BEDMAS stuff. So I always go 15 divided by, and then I keep sine 33 in brackets in your calculator. All right, so 15 divided by bracket, sine 33 close bracket. Let me know what you guys get. Rounding to 2 decimal places. Anyone get anything? Yep, 27.54. Good job. Let's do one more. So question number 9. Am I going too fast? Or are you guys okay with this? It's okay? It's all right? Is it enjoyable? So rude, but I'll try not to take it personally. All right, for the next one, again, we have the hypotenuse here, we have opposite here, we have the adjacent here, and we are going to, what are we going to use, you guys? We have adjacent, hypotenuse, but no opposite. Yeah, we have to use cosine, so it's going to be cos theta is equal to adjacent over hypotenuse. Theta is 43 degrees, so we're going to go cos 43 is equal to, adjacent is 36, and the hypotenuse is x. So again, the x is at the bottom. That kind of means we're going to have to do 2 steps. First, we're going to have to move the x besides the cos 43. And then we're going to have to now move the cos 43 to the other side and divide it. What'd you guys get for this? Yep, good job. 49.22. Right, resume recording. So 10 and 11, more of the same stuff. And then I want to get to the word problems. I know I said we weren't going to do word problems. The word problems I was talking about were like the intense, insane ones. These ones are just more of the same stuff. We're just drawing a picture and solving it. So it really will not be much more difficult or different than what we have been working on. All right, so our angle here is 72 degrees. We're going to call this hypotenuse. It's across from the right angle. This is going to be opposite, and this is going to be adjacent. So what do you guys think we're going to use, sine, cos, or tan? Yep, we have to use tan. So we're going to say tan theta is equal to opposite over adjacent. We're going to fill in our information. It's going to be tan 72 is equal to 25 over x. So once again, our x is at the bottom. We're going to move the x and then move the tan 72 over. Now, if you guys can kind of see that you're doing 2 movements and you don't want to show all your work, that's totally fine. So if you're confident now after 2 questions, you could just write x is equal to 25 over tan 72. Because you can kind of see that pattern, right? For every question, all we've been doing is moving the x to where the tan is and moving the tan to where the x is. Safir? Next class, tomorrow's class. So we're going to go 25 divided by bracket tan 72. Let me know what you guys get if you're using a calculator so we can confirm our answers. Did anyone get anything, Angela? I didn't get that either. Maybe I might have made a mistake. Did someone get something other than 76, Mangi? Yeah, me too. So just double check. You might have missed out a bracket or something. Okay, last question. Yeah, 8.2 is what I got as well. All right, for this one, this is our hypotenuse. This is opposite. This is adjacent. So what do you think we're going to be using? It's not going to be sine. It's going to be cosine, exactly, yeah. So it's going to be cos theta is equal to adjacent over hypotenuse. Cos 64 is equal to x over 11. Oh, this question almost snuck in because I noticed the pattern that the first four had the x at the top and the last four I thought would have the x at the bottom, but it turns out it didn't. It's just going to be one of the previous ones. You're just going to move the 11 to the other side and multiply these. What did you guys get for this? Yep, me too, 4.82. Thank you, Sarashnavi. I saw your answer as well. Good. Yep, 4.82 is what we got. All right. And now to end it off, let's try these word problems. Really, the thing about these word problems is they paint you a picture and you have to draw the picture based on what they're saying. So I'll draw a somewhat realistic picture, but not realistic. Jake leaned a 12-foot ladder against his house. So already I know that we have a house over here. And so I'm just going to call this his house. It's coming, it's coming. And then he's leaning a ladder against the side of his house. My gosh, the leg is just like insane. There we go. There. So the house is black, the ladder is red. We know the ladder that he leaned is 12 foot long. So I'm going to go ahead and I'm going to label this 12 feet. That tells me the ladder is 12 feet. If the angle formed by the ladder and the ground, so we know the ground is right over here. So if the angle that's formed by the ladder, which is in red, and the ground, which is green, is 68 degrees, I'm going to go ahead and write 68 degrees in there. So they're saying that little angle is 68. How far from the base of the house did he place the ladder? So what are we trying to find? Where should we put the X? Should we put it on this green line or should we put it where the house is? Safir? Yeah, they're basically just asking you for the distance from the base of the house, the base of the ladder. So we're trying to figure out this X over here. A word problem like this to me is quite fair. It doesn't really require any additional math. You're just reading the question, drawing a picture, and putting in the numbers. Okay, so let's go ahead and solve this. Just like before, if I labeled my different things, I have my right angle here. So that means this is the hypotenuse, this is adjacent, and this is opposite because the angle that's given is 68, right? So we base everything based on the 68. I feel like I'm starting to have like color. It's too much going on here. There we go. That's better. So I said, what did we say? We said that was opposite. Okay, so what do you guys think? Oh, now I erased all that. Sorry, guys. So this was the hypotenuse. This was opposite, this was adjacent. What do you guys think we're going to use? Sine, cos, or tan for this question? Yeah, because opposite is not given to us. So we're going to go ahead and use cosine for this. Let's do that. So cos theta is equal to adjacent over hypotenuse. We know what the angle is. It's 68. So it's going to be cos 68 is equal to x over 12. We've done this question a million times now, so you should be really, really comfortable with it. It's just going to be 12 times cos 68. I know sometimes I write it on the left, sometimes I write it on the right. It doesn't matter. In the end, you're multiplying 12 and cos 68. That's the end goal. It doesn't matter how you write it. So cos 68 times 12, you got 4.495. And we're rounding to 2 decimal places, so it's just going to be 4.50. And this will have a unit, which is just going to be feet. So he basically is placing, and you could write a therefore statement and a let statement. I'm not going to be too picky about these ones, but for the word problems we did virtually, make sure you have the full solution, let, therefore, check, and all of that stuff. And actually, we can also take up some of those questions Friday morning before we start our test, because I realized we didn't take them up today. Yep. Yeah, even if you did them for these ones, you should and could. I guess I'm just being lazy, but you could. Yeah. Yeah, sure. And now, Saphira, you're making me feel guilty. So we are going to add, let x represent distance from house to ladder. I mostly also didn't have enough room, so I felt like I wasn't including it because of that. But you know what? You're right. We should be including it. You guys over there, are you playing your video games right now? No. Oh, I'm sure. And then our therefore statement would be, therefore, the distance is 4.5 feet. Okay, last question. Am I going too fast? You guys okay? I just added a let and a therefore statement. All right, last question. I guess we'll draw it over here. A ramp is used to load suitcases on an airplane. If the cargo door is 7 feet from the ground and the angle formed by the end of the ramp and the ground is 25 degrees, how long is the ramp? So again, we have, let's say that this is the ground. Let's say that the airplane door is like up here and the ramp that is used to load, oh no. And the ramp that is used to load the suitcases looks like this. So the ramp is this way and the airplane door is like up there. So if the cargo door is 7 feet from the ground, that means from the ground all the way to the top of the airplane cargo door is going to be 7 feet. And the angle formed by the ramp and the ground is 25 degrees. I'm going to put the 25 there. How long is the ramp? That means my X is going to go over there. Your diagram may look very different than mine. It really is about how like you're visualizing it. But at the end, you need to know the ramp is the angled one, the ground is on the ground, and the cargo door is somewhere high up and the suitcases are going up. What do you think we're going to use for this? Sine, cos, or tan? Yeah, this is opposite and this is the hypotenuse. So we're going to be using sine. We're going to write sine theta is equal to opposite over hypotenuse. We know theta is 25. So sine 25 is equal to 7 over x. We know the x is going to be moved up and then the 25, sine 25 is going to be moved down. So it's going to be 7 over sine 25. And then we can solve this. And we're going to get approximately 16.56 feet. Which is, again, very realistic. If you have a door that's 7 feet high, then the ramp is going to be pretty long. Do you guys get 16.56? Yeah. We should include a let in a therefore statement. So I'm going to add that in. Actually, I'll let you guys add that in. So let, and then therefore, and then we're done. I know this lesson was super repetitive, but I feel with trig, the more questions we do and the more scenarios we do, you can get really good at them. Your homework is going to be the next 2 pages. So it's just more of the same stuff. I really like questions 12 and 13. I think I'm going to start tomorrow's class by taking up questions 12 and 13 because they have 2 triangles. So please make sure to do these for sure. And then the answers are, did I include the answers on that sheet? Okay, I'm going to post the answers on Brightspace so that you can at least check your answers before next class.